Hi, I'm Olivier Seberio, CEO at Senseen US. Olive growers face rising production costs and limited access to timely, actionable nutrient data, making it harder to optimize input and stay competitive. Right now, most growers rely on lab testing, but it is slow, costly, and too infrequent to guide in-season decisions. That often means over or under fertilizing or missing windows for corrective action. But with Nutriscope, we want to make nutrients diagnostics fast, affordable, and usable right in the orchard when decisions matter most. We are proposing a simple field-ready solution, calibrating our solution, Nutriscope, for olives so nutrients levels can be measured instantly without waiting on lab tests. Nutriscope is a handheld scanner that lets grower measure nutrients level in seconds. No lab, no waiting. It works by shining light across near infrared, visible, and UV to capture a spectral fingerprint on the leaf. We use machine learning to match those fingerprints to lab tested nutrients value. So you get real time estimates of nitrogen, calcium, potassium, and more, whatever Nutriscope is calibrated to. This is isn't this is not hypothetical. We have already calibrated Nutriscope on grape, tomatoes, wheat, corn, and other crops. So with the support from COC, we'll want to do the same for California olives, bringing that same power to these key permanent crops. And the way it works is actually very simple. So I'll do a demo. So this is a lime tree. We'll simulate that we are measuring wheat in this case. So the first thing you do is that you clip a leaf that you want to analyze using Nutriscope, and using your phone, you launch a scan. Voila. So it takes a few seconds for Nutriscope to do one scan. I'm doing a demo, so I'm doing only one scan now. A grower would have to do 15 scans in the field to get the measurements to reproduce, I would say, the lab processes. So in 15 scans, which represent 2 or 3 minutes of scanning, you get all these measurements at once. And voila. So the first screen is actually a measure of plant health. We define plant health as pH, redox, Brix, and conductivity. This is not part of the scope of this project, but could be added maybe next year if the project is a success or if you would like to continue. But this is interesting because it's represent a uniqueness of Nutriscope. We are capable not only of measuring pH but also redox, which is a pendant of pH in terms of oxidation. So together with pH, we are able to measure an overall stress level of the plant, which is the green diagram that you see on the graph here. And what we've seen so far by observation is that when we measure a stress index of 9 and below, the plant is healthy, can defend itself, can, I would say, grow and maintain its homeostasis. Above 9, the plant will be sensitive to stress such as fungi attack, pest, disease, etc., etc. So this again could be part of a second project, I would say, next year, if the first project is successful. Then the second screen is what concerns us today, is very much the measurements of nutrient concentration. So again, after 15 scans, you get all these concentration measurements right in the field. These are equivalent of SAP analysis. The reference lab we use is a laboratory located in the Netherlands called NovaCrop. And finally, for certain crops, we have a decision support system that enable growers to actually make sense of this data. So the decision support system is available only for corn and wheat today, and would require the participation of crop advisor and agronomist in its design if we were to design one for olives. So again, another project that we could develop later on. But the way it works, just as a demonstration, is that you scan, and then the system asks you probing questions, such as what is the stage of growth of the plant. So this is the case of wheat, and the condition of your root system. Again, this is specific to wheat. And based on that, it would actually make this recommendation. So because our plant here was healthy, and also it was not wheat, it was a lime tree, because the plant is healthy. There is no specific recommendation at that case, but he will recommend to look at the porosity of the soil, or the water retention capability of the soil, etc. So that's for the demo. Um, so the project that we would like to have financed by COC is based on a proven calibration workflow. So in 4 steps, the grower will receive a Nutriscope scanner and sampling kit. They would scan leaf samples and send them to the lab. So probably Novacrop also in the Netherlands. Then what we would do is that we would pair the scan data with the lab result and train the models. The model would be then deployed through the Nutriscope app for field use and immediately available to every grower who has a Nutriscope. The grant would be used to collect around 600 samples with the goal of retaining 500 high quality records for model training. Sampling will cover diverse conditions, such as different soil, location, management practice, to ensure that the model is broadly usable across California. The majority of the grant will fund laboratory nutrient analysis, which is a key cost in building accurate model. Senseen will contribute part of its labor in kind, and we expect the grower to provide labor in kind. In exchange, the growers will receive a Nutriscope that will be donated after the project and free analysis. All this coordination, the project will be coordinated remotely, so no travel cost. With this setup, we can deliver a calibrated all-level nutrient model within 12 months, while staying within a budget of around 50K. So this project delivers immediate value, a validated tool for real-time, cost-effective nutrient diagnostic in olives. But it also unlocks future potential. Nutriscope, as I say, can also track plant stress, pH redox balance, and physiological strengths, which could support broader orchard health and oil quality decision. We could also add the decision support system if that would intended if we get a collaboration in place. And finally, we are currently exploring nutritional quality of the food product. So who knows, maybe in few years, we could have the same scanner being able to scan directly into the olive and measuring key nutrient data for the olives. So in conclusion, we are ready to move. The method is validated, the tools are in place, and we are prepared to start onboarding olive growers this coming seasons. With support from the California Olive Committee, we can make nutrient monitoring faster, more affordable, and more effective for California producers. Thank you for considering our proposal, and we welcome connection with growers interested in participating. Thank you very much.